CLAAS Industrietechnik in Paderborn, Germany is a center of technical innovation. An impressive history unfolds in the factory halls that is inextricably linked with the renowned parent company, the agricultural machinery manufacturer of the same name. Since 1957, CLAAS Industrietechnik has been driving development in the areas of drive technology and hydraulics, with a dedicated workforce of more than 600 employees. For CLAAS machines, as well as external customers. A particularly innovative product line are the continuously variable transmission variants for CLAAS tractors. The components required for this are processed with maximum precision in 16 fully automated processing stations. The employees trained to automotive industry standards assemble around 700 components into one drive unit. To provide them with the best possible support, the company has always relied on appropriate first-class technological solutions in production. With the goal of increasing the efficiency of internal transports, more than 90 kilometers per day, CLAAS Industrietechnik has been trusting in the AMR and AGV integrator MR mobile robots and the autonomous transport system GOPAL from the Danish manufacturer Robotize since 2020. So we started in 2020 with CLAAS and first made a test position there. One robot, one charging station, 4 pallet stations. With these components, we have first mapped a basic process to find out whether the unit can work in this environment. Because the environment was quite demanding, attributable to oil from the processing machines, and because of metal chips as well lying on the path, we have had difficult ground requirements in the sense of very uneven ground. This resulted in many blows that the device had to cope with. We were faced with narrow driveways and a lot of passenger and device traffic. After 2 months of testing, we were then able to determine that the Robotize system can cope with these difficult requirements. In spite of the minimal space available, the robot works at its lowest limit. We have really created a lot of storage space here and a very fluid workflow for the employees. The robot we tested with was then replaced by the final model that CLAAS intended to use, a Robotize GOPAL E24. This type is able to handle payloads of up to 1 ton. With this first step, the initial process was finally implemented. This means that we no longer had 4 stations with which we only tested, but we actually equipped several processing centers and set up several stations in front of the washing plant in order to carry out this process of delivery and return of the goods carriers to be completely automated. As of today, processes have been introduced to transport goods away, which previously had stood in the production area waiting for the next machining step. These parts are now transported to the high bay warehouse by the robots and recollected from there when needed again. This makes the manufacturing area much tidier. You have more space, and you can work more cleanly. For CLAAS, advantages of the Robotize system are actually many-fold, depending on the process we focus on. It has been shown that the system is very well suited to automating a process that previously had been very strenuous for workers. As a result, heavy parts are no longer carried manually from the machining centers to the washing plant, and the goods carriers back again. We completely automated this by the Robotize system, resulting in corresponding capacities being freed up among the staff. Inconvenient processes, where men only walked through the production, have been eliminated and could be completely taken over by the Robotize units. Regarding the selection of the autonomous system, the choice has fallen on Robotize, since it is very flexible. In this environment, an AGV, for example, would not have been successful, since CLAAS is a company that has grown, a production environment that has grown. This means you have no wide corridors that are always free, that always look the same. This is why a flexible system is needed that can avoid obstacles and drive around them. A system which can also choose alternative routes when a track is completely blocked. Another advantage of the Robotize system is the item software updates. In this case, we have a very flexible manufacturer who accepts our suggestions for improvement and who delivers software updates which are at our free disposal. More functions are being added, and the customer's requirements were and still are specifically addressed. Different features were introduced especially for this customer, but they also bring added value across the entire fleet. This means such developments are not only customer-specific, but also bring added value again for each user of the system. As we told, CLAAS has started with one device, and then we went one step at a time here together with the customer. In this process, the system was not only expanded with Robotize components, but additional modules were also combined with it. This means not only were more and more machining centers integrated, but a washing system was also installed that had been specially designed for interactions with the Robotize system. As a result, the robots can now enter this washing plant automatically. The parts are removed from the carrier and fed automatically into this plant. The robot takes the goods carrier out again and puts it down, so that after the cycle, a worker can put up the empty carriers. And then these good carriers are returned to the machining center. With the insertion of the new washing plant, a completely new warehouse concept was also directly integrated. We are talking about this large area of stations you see here. The process is that the washed parts are taken out of the plant with a crane and, as it is shown here, are put into the mesh boxes. Once the boxes are full, they are moved to the warehouse. These mesh boxes, that's the key here. They always have to be positioned the right way around. Therefore, they are analyzed by a camera to verify whether the single box is empty or full, and if its alignment is correct. Depending on its status, the mesh boxes are then correctly sorted by the Robotize system and reintroduced into the process cycle again. We have seen that the employees were always positive about the replacement of the manual processes. It's nice to see all the interactions, not just between employees and AMRs, which is kept very simple indeed. We use manual call buttons. The operator just pushes the button, and then everything is done for him. At the same time, he also has a status display. This is partly solved by digital means, by the use of tablets or screens, as we can shift this status functionality, with more complexity, to the devices mentioned. In addition, we ensure the interaction of the AMR system with everything that is important in the manufacturing environment. The simplest example is the roller doors. The AMRs pass through a large number of roller shutters at CLAAS, some of which are sensor-controlled, but some of which are actively opened by the unit. Here we benefit from the advantage of having simple I/O boxes on board. These are very simple, small boxes which are fully integrated into the system. You can directly connect the roller gates, configure them, and they are included in the system. For example, in the storage area, we control LEDs via these I/O boxes. The idea is to signal directly to the employees, there are pallets here that now have to be picked up and taken to the high bay warehouse. This means also visual indications to trigger interactions with staff can be easily implemented. A very important aspect is also the topic of security, especially on the main corridor, where our robots are traveling up to 2 meters per second. Through a system that integrates not only our AMRs, but also the traveling forklifts, we project visual markings directly onto the intersection ground. No matter if a robot is coming now or a forklift approaches, people are warned visually. Another autonomous transport that has been implemented with our support is a metal swarf removal. In this case, 2 Robotize units are working in combination in order to remove full chip containers from the machining centers and reposition an empty container. A special requirement, namely that everything has to fit into the smallest space, which is just typical for the brownfield, where we can't reschedule, is particularly evident at the parts washing plant. Although this plant was newly installed, it still had to fit into the tightest of spaces. About 70% of all transports at CLAAS Industrietechnik are led to this new washing plant, meaning we have a real challenge here regarding traffic. This is because the transports usually do not arrive in an orderly manner and with a certain time lag. But, especially after the break, 3 or 4 robots regularly gather in front of the washing plant. This had to be solved. Indeed, we have an AMR system here that finds its own way, but even this feature is ultimately limited. Consequently, as the responsible integrator, we had to work very precisely and take many details into account in order to finally achieve a good workflow here, and to ensure a fine processing of all individual missions. And this is exactly what we have managed to do. As of today, the total system has grown to 6 robots. We have approximately 150 stations, and we are currently working on an expansion. For example, with a pallet magazine that is to be integrated. The robot fleet currently travels more than 90 kilometers a day, fulfilling about 500 single missions. That means that we are proud of a really productive and effective system here.